Hey, good morning. Welcome to this session about AI and .NET. My name is Cesar Torre, and I work as Principal Program Manager in the .NET team and ML.NET team. So in today's session, we're gonna talk about AI and what you can do with .NET and multiple components. So it's kind of a broader components than previous session about ML.NET. So we will be including cognitive services as well and positioning the different technologies, even bots. So let's start with very briefly for people that just came to this session, what is machine learning? And basically, machine learning is a way to create functions that it was very difficult to do with traditional programming. So for instance, you could create a function to identify objects, if is this a face or not. If you were doing that in a traditional way, it would be very complex, like trying to identify if it has a mouth or eyes, etc. But instead of that, or another example would be you want to say what's going to be the price of a shirt. So in order to do that with artificial intelligence, you need to train a model. And so therefore, you provide a bunch of data about faces. So you say this is a face, this is not a face. And then based on that training, the model would work. Okay. Something important is that you need a lot of data to train machine learning models. So let's go to next thing. Okay, so what problems can you solve with machine learning? There are many problems, and also those problems are related to more technical ML tasks. And this is kind of another world for developers, like many things like regression, clustering, anomaly detection, and so on. And what we want to do with Microsoft Development Technologies is to simplify this from a development perspective. And instead of like having to learn the low-level details about machine learning, even like those formulas for logistic regression or whatever, we just want to democratize so it is easy to use AI in general for developers. So let's first position the multiple technologies that we have for AI. And first of all, you could have technologies that you can just consume, like pre-built AI. And for that, you could use Azure Cognitive Services or other pre-trained models like Onyx, which is a standard, or Core ML, or Windows ML in your program. So basically, you are taking a pre-trained model and you're just running it or predicting what we call scoring, and just use it in your applications. So you're infusing machine learning to your current applications. But you can go further because you can also create your own AI, your own machine learning models. So for instance, we have multiple choices. You could use Azure Machine Learning Studio, or you could use machine learning.NET, ML.NET, or you can also use other deep learning technologies like TensorFlow, CNTK, or Torch, right? So for today's session, I'm going to be focusing on cognitive services and also on ML.NET. And of course, and then from ML.NET, you can also integrate with TensorFlow, as you saw in the previous session about ML.NET from Ankit and Gal. And finally, of course, you can use those models from any client app. So it could be a bot, could be a web app, could be mobile apps, or could be IoT edge devices, right? So let's start with pre-built AI using cognitive services. Probably you saw this slide if you saw any presentation about cognitive services. Basically, we are providing here higher level services that you can just use and consume, like computer vision or speech recognition or language understanding. And each of those kind of pillars have multiple sub services. So for instance, today I'm going to be focusing on computer vision in computer vision service and the custom vision service for the demos. So let's do a demo about that and using cognitive service, computer vision, and custom vision. For this demo, I'm using a a reference application forked from eShop on containers. So it's a microservice architecture-based application, but then we are extending eShop on containers with AI features or machine learning features. And this is so you can also reuse or surface all these features from multiple clients, the web or bot or even mobile applications, right? So let's move to the sample. In this case, we're gonna, so you see that I have here running the application in Docker because it's based on all these microservices are running as Docker containers, right? And then most of them are just like regular microservices accessing data, and some of them are using AI features. So this is the application. You can see that in the solution, you have many services, but just one is the one that we need to focus now, which is the one about cognitive services. So we'll come back into the code in a minute, but I just want to show you what we can do. So this is the eShop. You could buy things in the store, but the demo is, let's say you would want to search, but you, let's say the scenario would be a mobile application. You take a picture of something, and then you want to search if the catalog has something like that. Or in a comparable way for the demo, I could be searching in the internet, maybe for frisbees, right, like here. But maybe I'm searching a different language, like in Spanish, discos voladores. And then I don't really know, I have no clue about the name of this article in English, which is frisbee. So then I might save this into my hard drive, and I could search using object identification, right? So in this case, you can see that I'm using computer vision first. So if I provide that image, but first of all, I'm going to provide like an umbrella. And you'll see that it's working. It's going to be connecting to computer vision in Azure, which is a service that you can just use out of the box with a generic model. And then it's just calling to that service and identifying that picture and then searching in the catalog in my application. And you see that it is searching for other umbrellas as well. But if I search for the frisbee, like this one, you can see now that it doesn't work. It doesn't find any frisbee. And that's why, because that generic model is not finding that object. It's identifying that object as a dishware instead of a frisbee, right? So let's go to the code and see a little bit about it. So, well, first of all, I want to show you why, when using computer vision, you see that the name of that object was identified as dishware, and that's why it didn't work when searching in the catalog. So for that, you can use custom vision. So before getting into custom vision, I wanna show you the code about computer vision, which is just using that model in the internet. So it's basically, this is the microservice. I can just provide the API keys and the URL in Azure, and then just consume that and provide a picture, and it will respond with all the tags that that object was identified, and that is that simple. But if we want to use custom vision, the difference is basically two differences. So one is you can train with your own images, and secondly, it can be online or it can be offline. You can generate a model, a frozen model in a file, and run it in your program. So what you can do in this application, eShop on Containers AI is available in GitHub, in .NET Architecture eShop on Containers AI. Here you can see the architecture, extending eShop on containers, and so on. And then in the wiki, you see how to set it up. And one of the points is about custom vision, where the difference here is that you can create your service and then upload a bunch of images that you want to train, in this case about frisbees. And after you train it in Azure, in the internet, then you have two choices. You can You can run it online, like providing the key and the URL and then just doing a similar way than you use computer vision. Or the other way is that you generate or export a file, like a TensorFlow frozen model file, and then you can use it from your code. So for instance, in this case, if I use the custom vision, I just online, then I would provide the prediction key, and then I will call it with HTTP. But if I'm using custom vision offline, what I need to provide is the model file name. Like in this case, I would download the file, which is this one, model PB, as you can see here below, model PB. So I just need to load that file in my code and then provide the image and then run it. So it's offline, so it could be running in this web app, could be running a mobile app, offline, etc. Right? So that's the difference. And so I'm going to change and take advantage of microservices and change a variable in the containers. So to use custom vision instead of computer vision. So you can see here we are changing this variable to use this one to use custom vision offline. Right? It's going to use custom vision offline, and then just restarting the Docker containers using this using custom vision. So I'm going to run it here. You can see run and restart the containers. We might have like 12 containers. In this case, we just need to restart a couple of them. And then once it is restarted, if I go back to the application, you can see that I refresh the application, and then it's using now, and we're showing it, custom vision offline. So if we search now with a Frisbee image and run it, you can see that it's identifying this as a Frisbee, and then we get the right results in the application, right? So about the code, as I mentioned, you just need to provide the file image and then run it locally, and it can be completely offline. So let's move on to the next section. OK. So now let's talk about custom machine learning, and specifically using ML.NET. So the first question is, OK, so you have pre-trained, pre-built machine learning. Is that enough for me, like cognitive services? Well, as you might know, the answer is it depends. It might fit your needs, but sometimes you need something else. So for instance, if you use cognitive services, sentiment analysis service, and then you provide like this, this is a great vacuum cleaner, then that's a positive, right? But if you provide another sentence like this vacuum cleaner sucks so much dirt, that will be identified as not positive, and you might want to train this in a different way, right? So this is just one example, but there are many cases where you want to not just train with your data, like you can do with custom vision, but also there are other services in cognitive services that you cannot do custom training, and you might also use different algorithms. So for that, in custom vision, you typically have different phases. You prepare your data, you need to work with the data, message the data a lot, and then you need to build and train your own model. So this is the difference compared to pre-built AI, and then just run it or consume it or use it in your application, right? So in a little bit more detail in the process is you have a bunch of historic data, then you will be building your model and training with that data, and then you test it, you evaluate the accuracy of your models, and when you think it's good, then you generate a file, a model file, which in the case of ML.NET is a zip file, and then you run it or predict or score in any application, right? So you just saw a full session about ML.NET from Ankit and Gal. I just want to do a very, very quick intro about it in case you just came to this session. So ML.NET is a framework first. made for .NET developers. It's open source. It's especially made for developers. And it's proven and extensible because we've been using these libraries internally in Microsoft for quite a few years. And now we are making it public and simplifying it with a new API. And then currently we are in v0.5 in September, so we will be releasing version 1 in next year. And basically, if we go back to the process that we previously saw, you can build and train your models on .NET Core or .NET Framework, and by simply adding the NuGet packages of .NET, ML.NET in your application. And in the future, we will also provide a UI application model builder, so you can use it graphically as well. And then that zip file with your model, then you can use it in your application, which can also be .NET Core or .NET Framework. And simply by adding a NuGet package of ML.NET and loading that zip file and then scoring or predicting, right? So that's kind of the high-level process vision. And then what can you do with ML.NET? Usually ML.NET focuses most of all on the traditional machine learning problems with data, which is very useful for the enterprise, for instance. So you can identify if some data is A or B, which is binary classification, or you can predict how much about something like forecasting or clustering and so on, right? So there are many problems that we can solve with machine learning, like predict a value. It would be a regression, or something is A or B, binary classification, or detect issues or problems that might happen for instance, in devices coming a bunch of events, then you might detect anomaly detection, and so on, right? So we want to simplify this, so showing you problems instead of ML tasks in all the documentation and samples, and so we make it simpler to use. So I want to do a quick demo, which is about regression or a forecast of eShop dashboard. In this case, here the code. You see we have two projects, because now we need to first build and train the model, and then when we export the model or we generate a zip file, then we will use it in the web application. So that's why we have two separate projects or applications, right? So first of all, let's use the console application to build and train a model. It's a console application here. You can see it's a regular console app. And then we are going to be generating two models. In this case, one is for predicting forecast of sales specifically about products. And then the second model is about predicting or forecasting the sales for countries. So that's why we have two of them. I'm going to just go ahead and debug and talk a little bit about it. You see this is the console app. So we're going to create a model and train it for the first model. And then we will write the zip file after that. So you can see in here, this is kind of the important code. It's using API. This is the learning pipeline. It might change in a few weeks, but the important thing here is about the concepts. So first of all, you will load the file, like you can see here, the CSV, so file with data, with all the data related to sales about the products. And then in that CSV, we load it into the pipeline, and then we do a bunch of transformations. We need to concatenate data. We need to convert all the data into numeric vectors, and then we need to say what's going to be the label or what we want to predict in the regression. And so it's just like a concatenator, a vectorizer, and then concatenating all the features. And finally, we provide the algorithm that we want to use. In this case, a fast-tree two-digit regressor. You could test and try different algorithms and see which one is more accurate. And finally, we train, right? So just it's training now. You can see here training. And then once it is trained, then we generate the the file, right? So just finishes. It's going to go for the second model, but basically it will finish now. And then we have the two models. Okay. So these two models are generated here. If we go to Bing, debug, then you see the two models, one for the countries, one for the products. And these models, you can just copy those files into, like in this case, like a web application. We have the models copied here. And then I'm going to just run it so you can see how it works. Right, so in this case, it's just a monolithic web application, but we also have the same thing to eShop on Containers AI. Okay. So here's running the application. So let's try first a forecast for any specific product, like Jumbo. It's searching now the products. Let's select this one. And then here, you can see here all the historic data. And then this last piece of the chart is the prediction of the sales forecast, right? Let's do the same for country and then see some code of what we're doing. So first of all, we just need to provide what is the zip file of the model for the country, and then we provide the data that we need to evaluate and predict or to use for the prediction, right? Then let's go and predict. You see that we are providing this instance of this sample, and based on that, it will predict the forecast for this country. And here we are. It's for the country, and then this would be the prediction. Okay. Cool. So let's move on. So something we really want to highlight is that ML.NET is a framework first, and so it's basically libraries, NuGet packages, but we will also provide tooling for it, and it's for custom machine learning. So you can build and train, or you can then run any model. It supports .NET Core or .NET Framework, and then here are kind of the elements that you use with this API. You use transforms to make transformations to concatenate data within the data set that you're going to be using for the training, and then or convert to numeric vectors, featureize, and so on. Then we have learners or algorithms, the ones you want to use depending on the problem. And finally, we are also integrating or extending ML.NET with deep learning frameworks, like in this case, TensorFlow. In the previous session, I think you saw a demo about that. You can also go and see the blog post that I published yesterday in the .NET blog about the features in ML.NET 0.5. And there's quite a few information about the integration with ML.NET and TensorFlow. Okay. I want to really highlight that this is not something just new, even when it is in preview. We've been using internally ML.NET in Microsoft in products like Bing or Excel or PowerPoint or Windows 10. And yeah, just a final highlight about ML.NET is that it's also, we want to democratize custom AI or custom machine learning for .NET developers. So the difference is that we are targeting .NET developers with ML.NET, either for training models, and also we will provide in that, this democratization based on code, APIs, but also on a UI tool that will be releasing soon. And then finally, I also want to highlight that usually in the enterprise, you might have, like the enterprise might be researching not just AI, ML, but also maybe microservices and bots and so on. So that's why we are also releasing this sample or this reference application that I was showing. So you can see that in eShop on Containers AI is what you see in the whole picture, but eShop on Containers, so just the reference application for microservices would be the application that is kind of disabled here or grayed. And then we are extending that with AI with the demos that I showed, and also with a bot, which is the demo that I'm going to be showing now. So before doing the demo, I want to come back to the side of eShop on Containers AI, right? So in .NET architecture in GitHub, eShop Containers AI, you can see the wiki, all the multiple AI features. So for computer vision or pre-trained model, and in this case, you also have a section on how you can create a bot with bot framework and extend this application or kind of surface all the information, all the AI features that we have in the app with a bot. So for that, and then this bot is not just using our own services, it is also using LUIS, so language understanding in Azure. And here you have all the setup steps, like how you can create a register in Azure and create your LUIS account for that, and then create and register your bot in bot framework service. And finally, how you can run it and test it with the bot emulator that I'm going to demo now, and a few highlights about the code. Right. So it's ready for you to test this demo. I'm going to show it running to you. So basically, you can see that we have all these services running in Docker in this case. All the microservices, we're going to be in reality using this service that are using the sales, the bot, and then the one about cognitive services. So let's try it out. So here I have the bot emulator. So the bot emulator is an app that you can try locally, and you can provide the information about your bot. A bot is nothing else than another web API that you can add and deploy as a service, or in this case, we are deploying this web API in a Docker container. And here you provide the endpoint to that web API for your bot and the application ID. And finally, you just try it here. So now it's talking to the bot, to the web API. Here is responding, and then because it is already integrated into LUIS, we can talk to it, and it can understand depending on how we configure LUIS. But for instance, let's say I'm saying hello, and it is responding. Okay, so let's say I want to see products of the catalog. Okay, so I don't know, like show me products. Well, and then here we can see the categories. So we could be kind of navigating across the catalog, just using the typical flow of the web form. But also here we are surfacing AI features like the cognitive services custom vision that we use. And if we go back to the web app, we see that it's using now custom vision offline, so the frisbees should work. So I can also provide through the bot the image, and then is searching products about image. And here you can see the frisbees again, and you could enter into them or buy, etc. Right? So this is a demo about how you can also surface AI or any feature in your services through a bot. Let's see the code very briefly. I'm going to stop this. So if we go to the bot, services, and the bot is this. So we have two versions right now. We have a bot using .NET Core framework and a bot using full .NET framework, because the bot framework for .NET Core is still in preview. A few months ago, we were developing with the full .NET framework. But we really want to use the bot with .NET Core, because we want to deploy it as a container in Linux. So that's why we want the .NET Core version. So, and then the most important code here about the bot is this method in onTurn, where you will get the message from the bot client, and then depending on the message, it will redirect that into Luis, and Luis will send back what is the category of the message, and then we will redirect that into our dialogues. And then, for instance, the dialogue, the catalog dialogue, is the one that it's also talking to the custom vision for the image, and then querying this service with the product catalogs in the system and returning. Okay. Okay. And then something else that I want to highlight is about Azure Stream Analytics. So this is right now generally available, and you can integrate machine learning and also with ML.NET with Stream Analytics. So Stream Analytics is made so you can gather thousands, millions of events from devices, and then through IoT Hub. And then in real time, you could also create queries, and those queries could be also talking to your models, and depending on what you're predicting, you could do different things, right? That's one way of using Stream Analytics integrated to machine learning. A very typical thing would be for predictive maintenance, and then in real time you could be predicting what's going on the devices, if there's any issue. And then the other possibility is, and this is new, this is in private preview right now, but you can request access in that URL above. You can also use Azure Stream Analytics within an IoT device, run it on the edge, and gather the events from the devices. Like, let's say you have a Raspberry Pi doing that, or any other IoT edge device, and you run Azure Stream Analytics internally in that device. And you can also, and this is new, you could also, because this is C# as well, you could create a module in C#, which is a C# function, and then use ML.NET for scoring models. So any model that you created, you train outside, then you could reuse it within the IoT edge device, and then on the fly you could be predicting if there's an issue or whatever whatever the problem you're solving or you're predicting, and then finally communicating with the cloud. And that's almost all that I wanted to cover. So you have more resources in the .NET machine learning page. Also, if you wanna see kind of simple hello world, very easy to get started samples, go to github.net machine learning samples. You can also go to the ML.NET page if you want to see the internals about ML.NET and collaborate with the open source project. And also finally, you can also see this broader sample based on microservices extending eShop on containers with machine learning and AI in eShop on containers AI in GitHub as well. I also want to highlight the other sessions in .NET Conf about ML.NET. You might also have seen it, the session about ML.NET from Ankit and Gol. Then there's another session about cognitive services using Xamarin Apps from Veronica. And then, of course, this session that I'm just presenting. And yeah, so let's answer a few questions. Yeah, that's a good question. So it's saying, so when using Azure Custom Vision, do you need the custom model in the file, in the offline, in order to score for the Frisbee, the demo that I did, or can it also be online? Yeah, so I think I said that, but yeah, it can be offline or online. So when you train all those images in Azure, in the project in Azure with Azure Custom Vision, you have both approaches. You can extract or export the zip file and use it offline, or you can just use the key in Azure and the URL, and then from your service or your web application, you provide the key and the URL, and you just connect to Azure, to the service, and then use the model. Next question. Can we run ML.NET on Raspberry Pi with Windows 10 for IoT or Raspbian OS? I think you can use both. I mean, basically the answer is whatever you can run C# and .NET Core, you can run ML.NET. That's the answer. So in any device that you can run .NET Core, you'd be able to run ML.NET because it's just a libraries or a set of libraries and use it through a NuGet package. Another question is, what kind of AI/ML knowledge should I have in order to work with ML.NET? Okay, that's a good question because this is precisely kind of our related to the goals of ML.NET. So our goal is that any .NET developer researching with interest about AI and ML.NET, machine learning, could learn and do solve problems with ML.NET. Of course, it will depend. Like you without any knowledge about what is machine learning, you'd be able to do basic things and solve basic problems. Maybe would be a lot about retry and see what works better for you, what algorithms and so on. If you have more knowledge about machine learning problems and algorithms and approaches and working with data, then of course it will be a lot easier. But our goal is to provide also the UI, so that UI tool will kind of help you or drive you when you don't know what to use. Because so you will just submit initial data, your data set, and then it will make suggestions about, hey, this data looks like you want to, you could use it for a regression, and maybe this is the value that you could be predicting. And then if you want to do that, we suggest this algorithm or this 3 or 4 algorithms. And then you can play with that, you can try different approaches and then see and evaluate what's going to be better, and then just use it. Another question is, will ML.NET work on the client side of a web app with Blazor, similar to TensorFlow.js? So we haven't tested that, but initially it's a similar question that the previous one about IoT. So on any place that you can run .NET Core, initially you could run also ML.NET. So potentially, yes. Another question is about, do you need to define a graph statically before a model can run like TensorFlow? So I'm not sure about that question. If you mean about TensorFlow, if you just send me an email and we can get more details, I would need more information about that. What else? Can you see the other question? Yeah. Is there a way for ML.NET to leverage on GPUs for distributed training? So GPUs are mostly used, or you can take advantage of GPUs most of all on deep learning. So, and then initially in ML.NET, we target more traditional machine learning problems. So we are not using GPU for that. But if you are using TensorFlow, for instance, and you train TensorFlow, let's say in Python, then you would be using GPU, but you would be using just the frozen model in ML.NET. So initially, we are not using GPU right now. Okay, so with that, we finished the session. Thanks a lot for coming. Bye.